Right now, yes. All right. So we actually already learned this. Saxon only is teaching it tonight, but I taught it to you last week. Remember I was doing something and
This is dividing.
it's just dividing, right? So we're just going to review for a second what are our exponent rules that we know so far, because there's more than what we know so far. But we know the first one we learned was this: a to the m times a to the n
Equals a to the m plus n.
equals a to the m plus n. You're adding the exponent as long as they're the same base, right? The same base. The a has to be there in both of them, right? Then you just add the exponents, and then that's called the product rule. Why would you call it the product rule?
Because it's for multiplying.
Because it's for multiply. Product is the answer to a multiplication problem, right? So that's called the product rule. I don't actually know what everything's called here, but that's okay. The next one, the quotient rule, we'll do that one now, which I taught you the other day. A to the m over a to the n is equal to
1.
A to the m minus n.
Yeah. So see that line there, the division line? I think of it in my brain, I think of it as that's a gigantic minus sign. Gigantic minus sign. So I think, oh, well, they're the same base as a and a. So I go a to the m minus n. So a to the m minus n. So that's called your quotient rule. And then another one we know is this: a to the negative m is equal to 1 over a to the positive m, right? And then there's another one that sort of goes along with that, which is 1 over a to the negative m is equal to a to the m, right?
1 negative m.
And I don't know what those are called. Do you know what those are called, Nate? Negative, I don't know. Negative exponent rule? Negative exponent rule, maybe? I don't know. But, well, it doesn't matter what it's called. But
It's called a rule.
all right, so those are the ones we know so far. There are actually more. We're going to get into the others, eventually. I haven't looked through Saxon to figure it out, but figure out where they're going to talk about it. But if we need them, I'll teach them. You know what I mean? As we're going along. But so let's think about this again. Quotient rule for exponents. So if we had, let's just do something simple. We have x to the 10 divided by x to the 6.
X to the 4.
It would be x to the 10 minus 6, which is x to the 4, right? Exactly. Do you guys believe it? Does it make sense to you?
Yeah.
Like if I did it in longhand, right? What's x to the 10? I don't really want to. X times x.
We'll just do x
times
to
x
5 or
times
7.
x times x times x. Am I doing this right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's x to the 10. This is x to the 6. X times x times x times x times x times x. Right? So x over x is equal to 1. Right? X over x is equal to 1. 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 What do I have left over? X to the 4th. Right? So that's why this is a shortcut. This is the real thing. This is just a shortcut. Right? You see the difference?
Yeah.
That's the real thing. But I don't want to do the real thing all the time. As a mathematician, I have better things to do with my time than to do this.
Yeah, what if you had a really big
If
number?
you had like x to the 497,000.
Oh man, that would be hard. We should try that.
Right? I would not want to do that the long way. Yes?
Would that be a negative exponent if you did that one? Or
Yeah, so that's what I want to talk about today a little bit. Because this is the rule But it doesn't always, there's another way to think of that rule than that rule that I find useful. Okay? And so, yes, if we did this the way this rule says, look what we'd have. We'd have x to the 264 minus 4922, which is, I don't know what that is. Anybody know?
You could have made them easier.
It's
Why do I do this on the video? I do this to myself all the time.
It's like 3,000 and
Something.
3,000 and
Hopefully some helpful math.
Are you doing it?
Yeah.
3,656. Negative something.
3,600 and negative and 56.
Say it again. I'll go with you.
3,656.
Does that sound right?
I have 4,648. What?
648?
I got 4,648.
No, you added them. You got to
No, I
subtract them.
subtracted.
Just subtract 264 from this.
Yeah.
Do you guys remember how to do that?
Yeah, I did. That's right. I'm just doing it in my head.
4 from 12 is 8. Yeah, so it's got to
Yeah,
be.
minus 200. 922 minus 200 is not going to.
Wait.
4,922
Alright.
minus like 300 is not going to go down.
Okay, yeah, but I just, well, whatever. Well, it's okay. I'll do it.
Yeah, sorry. I was
4,922
thinking that was like
minus 264.
1,264.
Sorry, this is on video. I've got to do something. Okay, so that's going to be a 1. This becomes a 12. 4 from 12 is 8. 6 from 1 is impossible, so I'm going to make that an 8. Make that an 11. 6 from 11 is 5. And then 2 from 8 is 6 and
4,000.
I made that a 3.
Okay,
by the way.
so I
3.
only subtracted.
So 3, 6, 5, 8. There we go.
See, I told you.
Okay.
You can subtract
Alright.
2 from 8,
Gary,
Gary.
you didn't make that a 3.
Yeah, why did you make that?
It'd still be a 4.
It's still a 4.
Oh, you're right. It is a 4. You're right. I'm
Borrow.
sorry. I was
4.
thinking it had to be. You're right. Sorry.
Gary, all you have to do is
Thank you so much for coming to my video. This is great.
And then
All right,
that's
4.
a 7.
Okay.
And then that's a 7 over there. That's a 7.
Thank you. That's one of the reasons I have Nate in here. to
Wait,
keep
9
me
minus 2
on
is
track.
7. 9
Okay,
minus 2
Hunter.
is 7.
If you want to know the answer to something but you don't know it on the video, you should just put the answer in the comments.
That's true.
Okay, wait. No, 9 minus 2 is 7. Oh, wait, never mind. Sorry.
All right. I think even if I'm wrong, we'll keep it. Okay. We'll just assume I'm right. Okay.
I think
So-
that's right.
So, but look what we got. We got x to the negative 4,000 something, right?
Yeah.
Which is okay, but there is a rule in math that they don't talk about yet in this chapter, but there is a rule in math that you're not supposed to leave your answers with a negative exponent. That you actually are required or expected to rewrite it with a positive exponent. So how could I rewrite this with a positive exponent? So, Amy.
1 over x to the negative, to the 4,600.
Right, so you're using this rule, right? Wherever, that rule. So it's going to be 1 over, is this on the
X to
video?
the
Yes.
400.
X to the 4,658, right? So that's right. So in order, we started with something that was a very simple, well, maybe not that simple, but a quotient that we used the quotient rule on. But when we got to the end, the answer, the quotient rule wasn't enough. We also had to know the negative exponent rule, whatever, right? You know what I mean? To go to the final answer. So I want to show you how to combine those two. Okay? So can I erase all this? Probably.
Yeah.
Okay. So watch this. What if I said x to the 10 over x to the 3rd? Now I'm just starting simple. We all know that it would be, using the rule, it would be x to the 10 minus 3, right? So that would be easy, and that's how I would normally do it, because that's the easy way. But I'm going to show you another thing that you could do that actually is useful with more complicated problems. Okay? But I'm doing it simple first, so that then when I show you a complicated problem, you're going to see, oh, I see, it's so easy. What happens to an exponent? Remember these rules?
Yeah.
What happens to an exponent as soon as you take the exponent and the number that it affects across the division line?
It changes it. If it's positive, then it becomes negative, and if it's negative, it becomes positive.
Right. If it's positive, it becomes negative, and if it's negative, it becomes positive. So this is the trick. Ask yourself which one has the smaller exponent. X to the 3, right? So I'm going to bring the x to the 3 upstairs, which is times x to the negative 3. And then downstairs is just left with a 1, because there's a hidden 1 right there. Right? 1 times x cubed. The x cubed, the cubed only affects the x, not the 1. So the 1 stays. Right?
Yeah.
So what do I have? What's x to the 10 times x to the negative 3?
X to the negative 7. I mean x to the 7.
X to the 7 over 1, which is the same as x to the 7. All right? So, all right, so now let's try another one. X to the 12 over x to the 5. If that 5 goes upstairs, it's going to be x to the 12 times x to the negative 5, which is x to the 7 again, right? Okay? Now watch. Now here's where, when you put it in, this is where that's useful. When you put it, well, let's do one more. Let's do one more, because let's try this. Let's say we do x to the 22nd over x to the 44. What would I do?
You move the x.
Bring the one with a littler exponent, I'm going to bring it downstairs, right? So now I'm going to have 1 over, because that's going to relieve, when I bring that down, there's still going to be a 1 there to hold its place. And then we've got x to the 44 times x to the 22, negative 22, which is 1 over x to the 22, right? So this is where this is useful. If you get a problem like this, x to the 4th, y to the 12th, z to the 11th, all over x to the 9th, y squared, and z to the 7th. Right? So, if I did just that quotient rule, which is there's same bases, x and x, right? And I did 4 minus 9, then I'd have a negative exponent. You see what I mean? Then I'd have to deal with that. I'd have this something with a negative exponent, and then I have others that are going to have a positive exponent. It would be easier to do it all at once, like this. Draw my line. I'm going to bring the littler one down, right? See what I'm doing? The x, there's 2 x's, x bases. That has the smaller exponent. I'm going to bring that down. What is 9 minus 4? 5. So I'm going, because that'll become x to the 9th times x to the negative 4. 9 minus 4 is 5. So now I have x to the 5th downstairs. Here, I have y to the 12th over y squared. Right? So, smaller exponent, I'm going to bring it up. So y to the 12th times y to the negative 2. What's 12 minus 2? So, upstairs I have y to the 10th. Here I have z to the 11th, z to the 7th. I'm going to bring the one with the smaller exponent upstairs. Becomes z to the negative 7. Z to the 11 minus 7 is 4, right? So z to the 4. So I just, in one foul swoop, went from here to here and I'm done. Right? Whereas if I had used the quotient rule the way it's written, it would have worked, but it would have taken me longer, because I would have ended up having, like if I used the quotient rule, this is what I would have gotten. I'll redo it. X to the 4th, let's see. Y to the 12th, z to the 11th, over x to the 9th, y squared, z to the 7th. This is what I would have gotten. I would have gotten x to the 4 minus 9 right? 4 minus 9. Y to the 12 minus 2. Z to the 11 minus 7. Okay, so now I'm going to simplify that. I've got x to the negative 5, right? Y to the 10. Z to the 4th, right? Okay, so I still have this doggone negative sign, right, in my exponent. So I got to rewrite it again. What I'm going to do is I'm going to put it over 1 to make to have a fraction. And then this I'll bring downstairs. So then my answer would be y to the 10th, z to the 4th, over x to the 5th. So I got the same answer. They both were relatively easy, but this one took 2 steps. I went from here to there, and then I had to bring it down to here. Here, I went from here immediately to the answer. Did you see what I'm saying? Does it make sense? Fist to 5? Am I losing you guys?
I'm like 4.5.
Really? You get it?
8,
That's awesome. That's amazing. I'm impressed. All right. So, gosh, it's almost over, isn't it? All right.
You got 1 minute.
Yeah, 1 minute. Did I cover everything? Oh, well, and then, so where you might see this on the homework tonight, don't ring the bell, Nate. Okay?
4 1/3.
Did he leave? Oh, okay. All right, where you might see it on the homework is, you might see it says in the distributive property of rational expressions. So watch this. If you have, I guess I shouldn't do that one. That's the homework. Okay. We'll do, okay. K squared b over p to the minus 2 times, God, this is hard, a b to the minus 1 over k2 minus 4p squared over b. 4p squared over b. All right, so that looks like a nightmare to me. Right? Doesn't that look, I mean, but it's not so bad. You do have a negative exponent, right? Now, I would probably just leave them, I would just multiply numerator times numerator and numerator times numerator, distributive property. Numerator, distributive properties, and then denominator, distributive properties. I do this times this times this. And then I would simplify at the end. I would simplify at the end. So I'm going to say k squared b times a b to the minus 1. Well, I know there's going to be a k squared. There's nothing a k squared. Now what is b times b to the minus 1?
B to the 0.
b to the 1 times b to the negative 1 is equal to b to the 1 minus 1, which is b to the 0.
Which is B.
And you guys learned that, right? That was in Saxon, right? You learned that.
Yes.
Anything to the 0 power is 1. So that's going to be b, or well, just 1. I didn't even have to write it. Right? You see what I'm doing, though? I'm just distributing it. That's all.
Okay.